Welcome CS302 to our next assignment, and this is going to be on bowling. Yes, the game bowling that we all just go with our friends to go play, and nobody can really bowl at all, but we try our best anyway. So this is going to be based on that classical game bowling, except this program will be a little bit different. So basically, I guess the idea is you want to knock all the pins down with a ball whenever you go bowling, and the pins are typically arranged in a triangular shape. So this program is going to be a bit different. It will be a turn-based bowling game where the way this game goes is you'll have player one and player two, or we could say maybe you and then your opponent will play. You'll take turns throwing a ball at pins. Now the pins are going to be arranged horizontally in front of you. And then with the ball, so you'll assume that you and your friend are both very good bowlers where you can always knock at least one pin down. So if any pin remains on the field of play, I guess I'm going to call it a field of play. If there's any pins left, you can of course hit that pin. Now if you have two pins that are next to each other, you can also be able to knock two pins down at one time. So you and your friend or you and your opponent will alternate turns one after the other, and then basically the winner of the game is when the person who knocks the last pin or pins down, and that person wins, another person would lose, obviously. So basically, the idea is that you and your opponent are both going to play optimally. So what's going to happen is you're going to use recursion to simulate this game, because think of it as like a game where you have a checkpoint or a save point, and then you progress through the game. So imagine any game. You save the game at a checkpoint, you keep playing, you make decisions in the future, and you get into a point where you messed up so bad in the game that you have to go back to a previous save point and try a different path or try a different sort of decision. That's going to be the idea for this program. So really there's no class to write, just a recursive function you're going to have to write. So I'm going to go ahead and sort of walk you through this sort of program. So in this one, the input is going to just be, well, you're going to be given sort of a string which contains either an I or an X arranged in an array type of form. So it'll be in a string, you have to read it in as a string into the program, and then of course a string is an array of characters after all. And each position will contain either an I or an X. So an I means a pin is at that location, X means there is an empty spot at that location. So of course that's your input. You read in that initial bowling formation, and then of course you output whether it's possible for you to win. You output you win. So if you and your opponent both play optimally, but both playing optimally will lead to you winning, you output you win. And you output you lose if, let's say, no matter what you do, there's no way you can find a method of being able to win. So I'm going to go ahead and go over the recursive function for this and sort of give you an idea of how you want to approach this program. Alright, so this is an idea of the recursive function you're going to have to write. So of course, not of course, but I'll kind of give you an example as to why you want this to return a Boolean value, because a Boolean will kind of tell, it's going to basically tell the opponent or yourself if a decision led to a win or a loss. So of course you're going to pass in a string which contains a formation. So basically each function call is going to be sort of a decision made by either you or your opponent. It will spawn a function call and the game will continue. And the idea is that with recursion, think of recursion as like in a game where you have a save spot or a checkpoint, and after your checkpoint is reached, you go ahead and make some decisions which leads the game to a really bad spot where you cannot win from this point. You made some bad decisions, you fought the main boss too soon, and for some reason now it saves the game on that boss fight, and you're thinking, well, I can't win this without leveling up my character or so. So you can go back to a previous save point and then try other ideas to have a different path instead, which this one might lead to a win. That's sort of the idea of how recursion can be used in different applications. So Of course, you can make the function different. I mean, I called it bool. You can call it whatever you want to call it. You can pass in more than one parameter, but I recommend having it as a Boolean return type. Okay, so now that we have that sort of out of the way, let's now go into how do we actually visualize the recursion for a potential problem. So let's say right here in the input, you're going to read in this string. So again, it's arranged horizontally. We have 2 pins right there, then 2 blank spots, then 2 pins like this. So initially, here's our initial arrangement of our pins. And of course, you're going to make the first move. So is player 1's turn or your turn first. And then of course, every recursive function call will alternate between, so it'll be a turn-based situation. So let's go ahead and go into how we can visualize the recursion for this problem. Okay, so obviously after you read in this string in main, your first function call, you're going to first call function in main, and you're going to pass this string into that function. So this is going to be just your initial sort of formation. It's going to be your first function call. So in this first function call, it's going to be your turn. So I'm going to redraw this rectangle so it does look a bit more, I'll go with that. So now it's your turn. Okay, so being your turn, you make the first move, and okay, let's be consistent. So I'm gonna first take out that pin. I'm gonna start with this as the first non-X I can see from left to right. I'm gonna first go ahead and knock this pin down. Okay, so then my formation now I'm going to have is gonna be X, I, X, X, I. So what happens is, I create this new formation. I'm going to pass this in to a new function call. So with recursion, you pass this function, this string in. So these red boxes is going to denote a function call. So this is our first function call right there. And this function spawned this function. Now with recursion, remember, what happens is this function above is not done, except that it's waiting and then it's going to have some return back. So we're going to return a true or false value back, which will help us determine what we'll do next. So anyway, I'll put a line here. So the first function call right there, this was our turn. Now it's going to be your opponent's turn right there. So your opponent is also going to play optimally. So right now, your opponent will say, well, okay, as I look through this, I see that this pin right here, I see a pin right here. So I'm going to go ahead and just knock this down, just because, why not? So when I do this, I'm going to end up getting X, X, so 4 X's in a row. And then of course we have our 2 pins right there. So this will again spawn a new function call. So literally on every function call, I go through my formation and I decide to either just knock a pin down or knock 2 pins out. Right now I decide to knock only 1 pin down. Okay. So this was my turn. This right here is my turn, opponent's turn. Now it's my turn again. So after every function call, it's going to sort of alternate between you and your opponent. So this is my turn, opponent's turn, my turn again. Okay, so now here we are. Being my turn, I'm going to go ahead and say, I'm going to knock down this pin. That's the first pin I can see from left to right. That's not the first character from left to right. It's not going to contain X. So I'm going to go ahead and knock that pin down. So I'm being consistent. This is how I wrote my code actually. So here we have the following. So 5 X's. And then I, which is going to represent a pin that we still have. Okay, so let's see, let me just double check. This is my turn, opponent's turn, my turn, opponent's turn. Okay, so now it's the opponent's turn at this moment. So your opponent's turn, obviously the only move the opponent can make is to knock this pin down. That's the only non-X character in the entire string. So if the opponent knocks this pin down, that means the opponent would win. Because at this point, the opponent made a move and there's no pins left. So then what happens is you're going to return some type of value back up this tree, up this recursive call tree. A true or false is returned, basically. So what that's going to tell us, so you have to determine what a true or false represents, but either way, when we go back, so this function call is now gone. We destroyed. So basically this function call doesn't exist anymore. That was a base case was reached because knocking this last pin down led to all x's, so we hit a base case. Return a true or false value back up. So what happens is when we're back at this level, we go back over here to this previous checkpoint, and we saw that when I knocked this pin down, it led to my loss. So I want to play optimally, so I know okay, so think about this. I saved my progress, and I made a decision. So I guess like in Breath of the Wild, I'm not sure if Breath of the Wild does this, but let's suppose it did that. So I take on the final boss, the Calamity Ganon. I think that's the final boss in Breath of the Wild. So I hadn't upgraded my character at all. I have no weapons, no healing items, nothing. I go and take on Calamity Ganon and get destroyed. I didn't even unlock the Divine Beasts or anything, so I get destroyed right away. Let's say the game happens to always save at that boss fight. So, okay, I can't win this. So I want to go back to my previous save point, which is right here, and I'm going to decide differently. So I'm going to now say, you know what? I'm going to go ahead and take out these 2 pins. So we have 3 decisions. I can either take out this pin, or I can take out both pins, or I can take out just that pin. So I first did this pin, led to a loss. So let's go ahead and take out these 2 pins now instead. If I do that, then that's going to lead to a win for me, because now if I take these 2 pins down, they're all x's, so I win this time. So this function now is done. I return a true or false value back. So going back to my opponent, this is my opponent's turn right there. So when the opponent made this move, that led to a loss, because taking out that pin, if you know, in this case, so right now we're in the opponent's shoes right now. So if I'm the opponent, doing this led to a loss because, you know, you, player 1, you played optimally, you played smart. You made the choice that leads to a win. So in this case, if I make this move, my opponent will beat me. So, okay, fine. So I'm the opponent. I'm going to say, you know what? I'm going to instead maybe take out this pin instead. So I tried this one before, led to a failure. Let's try this one instead. So if I do this, if I knock this pin down, I end up getting X, I, X, 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 and I. I end up getting this formation. Okay, so let's see if this one leads to a win. So this path right here, this path I chose earlier, led to a failure, loss for my opponent. Let's hope maybe this path will lead to a win. Let's see. So now it's going to be my turn because my opponent had this formation. Opponent took out this pin. So now it's my turn. Okay, being my turn, I'm going to go ahead and say, you know what? I'm going to go ahead and take out this pin right here, since it's my turn. Okay, if I do that, then it'll be my opponent's turn with this formation. Like that. And now, being my opponent's turn, my opponent will say, well, he or she will take that pin down, which will make everything all X's, which will lead to a win for my opponent, which means a loss for me. So this path, so obviously a base case happens, and it returns a true or false value, which is going to tell us something, which is going to help us decide what do we do next. So it returns some true or false value, which is going to denote that if I take this pin out on my turn, it leads to a loss. So, okay, fine. How about I try to take this pin out instead? Because let's try a different move. Maybe this one will lead for a win for me. I don't know. Let's go ahead and give it a shot. So we end up getting actually this formation. Because in this formation, I took out that, I'm sorry, it's supposed to be an X over there as well. So in this formation, if I made a decision to take out this pin instead, then this is going to be the new formation that's a result. And again, my opponent is going to play smart. So my opponent will say, well, okay, I can take this pin out, which leads to a win for me. So it returns a true or false value back up, which for us, we have to interpret this as a loss. So when it was our turn, right here, this was our turn. So no matter what we did, either way, we lost. So we return a value back up. So we hit a base, not really base case, but we tried every possibility, so we have nothing left to really do at this point. So what's going to happen is the following. So right now, this is going to be the opponent. So this is the opponent's turn with this formation. So when the opponent happened to choose this decision to take out this pin, which led down this path, it led to a loss. So when the opponent took out this pin and took this path, it led to a win. Because when it was our turn, so right here was our turn right there, when it was our turn, no matter what we did, this path or this path, either one led to a loss. So if the opponent takes this path, the opponent is guaranteed to win, if that makes any sense. So that means, we can return back and say that, okay, this path leads to a win for us, going way back to the beginning. So this function call is now over. We return a value back. So this tells us that if I made this decision right here to take this pin and go on this path, that leads to a loss. So if the opponent plays smart, the opponent is going to guarantee to beat us, which means that, okay, I don't want to take that path because that path, is going to lead to a loss for me. So I'm going to go back to this point and say, you know what? I'm going to try a different decision. So imagine, again, I save my progress right there. I save my progress right here. And I took this path, leads to a loss. I'm going to go back to my previous saved checkpoint and maybe try a different decision. So I'm going to try maybe I'll take out both of these pins. I first took out this pin, led to a loss. So what if I take out these two pins? Maybe this one's going to lead to a win. So then I have to go ahead and call a new function call. I'm going to pass this string into this function and try a different path this time around. And sort of, I guess I can sort of continue with this. So it's going to be my opponent's turn right now. So my opponent has a few decisions the opponent can make. So with my opponent being in this formation, well, the opponent has a few options. So what we can say is the opponent can try to take this pin down, but if the opponent does that, it will lead to a loss for the opponent. If the opponent takes down these two pins, the opponent will win, which means, okay, then the opponent will go with that decision, which means that this path for us also leads to a loss. So basically the way this game is going to work, this recursive sort of algorithm is going to work, is as follows. When it's our turn, if one of the paths we take leads to a win, we take that path. But the opponent will also play the game the same way as well. So let's say if the opponent is at a certain, so either you or your opponent, if you're at a certain spot where every decision you make all leads to a loss, then for you, this is a failed situation. So for us, let's say over here, like in this situation, like let's say we have this formation. So this is going to be, I believe, a loss, whereas in no matter what path we take, we have multiple options, but every option, I believe, is going to lead to our eventual loss. So the idea at that topmost level, when it's our turn, if one path leads to a win, we take that path. Every path leads to a loss, then we lose. That's the idea. So every level, that's going to be the rule. So over here, for example, when it was our opponent's turn in this situation, this path led to a loss, that path led to a win, which means that, okay, the opponent can win. So for example, if the opponent would try all possible paths and all of them would lead to a loss, then for us, this path is a win for us, because if you choose this, every path loses, we win. But unfortunately, this path, if the opponent took this decision, where the opponent happened to, let's see, take out this pin right there, then it led to a win for the opponent. Actually, wait, let me just see if I'm have everything together. Yes, it leads to a win for the opponent. Yes, exactly. So that's the idea. So that's how you want to work this out. So you have to be at every function call. You have a formation, and then you make a move and then call a function on that move, and then a value, a true or false value, is returned back to you, and based on that you determine, oh, this path led to a win or loss. It led to a win, okay, then that's it. We win at this level, so we're good. If it leads to a loss, we try other paths. So obviously, the game is we win the game if at this topmost level there's one path leads to a win. We lose if every single path leads to a loss. So I typically don't give out too much algorithmic help like this, but recursion can be a relatively challenging topic, so I don't want to really leave you too much in the dark. But just think of it, every function call is a move that was made, is a save spot. And of course, when we return back up, it's sort of we going back to a previous save and see what happens. Now, of course, let's say, for example, if we have a win, then we automatically relay that true or false value back up this recursive call tree. If it leads to a loss, we try other paths. If all the paths lead to a loss, we return a value back up, and then of course the function above will decide what to do based on true or false value that's returned. So I didn't give out really any of the code, but this is sort of the idea. So think of how you could write recursion to do all this. So I hope this video is relatively shorter, but hopefully it did help you. So I guess happy coding, and of course, as always, take care, guys.